Bismillah ar-Rahman ar-Rahim. Assalamu alaikum. Today we'll start with section 3.2, the derivative as a function. In the previous section, we learned how to find the derivative of a function at a point. Today we will learn the derivative of the function as a function. Means when we differentiate the function, we will get a new function. So the derivative of the function f of x with respect to the variable x is the function f prime whose value at x is given by this equation. F prime of x equals limit of f of x plus h minus f of x as h or divided by h as h goes to 0, provided the limit exists. It's quite similar to the previous definition, but here we are not finding the derivative of the function at x equals c or at x equals x0 or at x equals any value. We are finding the derivative of the function at x equals x. So the result will be a function of x. Let's see this example. We need to differentiate the function f of x equals to x divided by x minus 1. So we use the definition of the derivative, which requires us to calculate f of x plus h and then subtract f of x to obtain the numerator in the difference quotient, and then we have to find the limit. This is f of x, which is x divided by x minus 1, and f of x plus h we can be found by substituting x by x plus h. So to find this function f of x plus h, we need to substitute in the our f of x instead of x, substitute x plus h. So you will get in the numerator x plus h, down you will have in the denominator x plus h minus 1. So use the definition and then substitute these f of x and f of x plus h in this definition. You will get the limit of x plus h divided by x plus h minus 1. So this is the first term, is what we evaluated just now, f of x plus h, minus the second term is f of x, and divided by h. Okay, simplify the numerator. Multiply these two fractions, expand the fractions, and expand the brackets, and then you will get to this very simple fraction minus h divided by x plus h minus 1 times x minus h. And we have here in front 1 over h. So if we divide by h, we will get this very simple form, which is minus 1 over x minus 1 in a bracket square. So this is the derivative of the function. See here, the answer here is a function of x. So this is a new function of x, which is the derivative of the function, and we give it the symbol or the notation f prime of x. So the function f of x has a derivative which is f prime x as minus 1 over x minus 1 in a bracket square. And then later on, if you want to determine the derivative at any point, then you need to substitute x by that point. Okay? Let's see another example here. Find the derivative of f of x equals square root of x for x greater than 0. And B, find the tangent line to the curve y equals square root of x at x equals 4. So for the first part to find the derivative, we need to follow the definition. Okay, so we can substitute here instead of f of x square root of x. Instead of x plus h, we can substitute instead of x plus h. Well, here in the solution which you see, the x plus h is defined as z. Okay, you can call it Z. And this is another form of the definition. This is exactly equivalent to X, the original definition, if Z is assumed to be X plus H. Okay, so if you assume Z equals X plus H, then you follow this definition. And then if you substitute in this definition, ultimately you will get the answer as 1 over 2 square root of X. Now for the second part, we need to find the tangent to the curve, the tangent line to the curve at X equals 4. So if you substitute X by 4 here, you will get f prime at 4 equals 1 over 4. This is what? This is the derivative of the function at x equals 4, and which is equivalent to the slope of the tangent line at x equals to 4. So if you want to find the equation of the tangent line at x equals 4, then you can use the formula, which is the slope equals y minus y0 over x minus x0. Now x0 is equivalent to 4. How about y0? y0 is f of 4, means the value of the function at x equals 4, which you can find it by substituting in the function. So this is square root of 4, that is 2. So when you substitute instead of y0 4 and x0 2, and instead of m is 1 over 4, which you find it from the derivative, then you will get this equation for the tangent line to the function at x equals 4. So this is the way we solve questions on this definition. Here we have some notations that are used in many textbooks for the derivative of the function. So if y equals f of x, x is the independent variable and y is the dependent variable. So the notations used for the derivative are, all these are notations used in the textbook. You can write it in this way: f prime x, or y prime, or dy by dx, or df by dx, or d by dx f of x, or d capital letter in a bracket f in a bracket x, or d sub x f of x. So you can use any of these notations to denote the derivative of the function. The famous ones are the first, second, third, maybe the fourth and fifth. Okay. Here we have a theorem. The theorem says this relates the differentiable function and the continuous function. So the theorem says the function is continuous at every point where it has a derivative, which means that if f has a derivative at x equals c, then f is continuous at x equals c. So if you prove that the function has a derivative at certain value of x, then the function is continuous at that value of x. But the other way is not always correct. If the function is continuous at x equals c, doesn't mean that the function has a derivative at x equals to c. Here we have some exercises from your textbook. Let's solve the first one now, and then the rest can be tried. You can try them at home. So using the definition, calculate the derivative of the function in these exercises from 1 to 6. Then find the values of the derivative as specified. So here we have f of x equals 4 minus x squared. We need to find f prime at x equals minus 3, at x equals 0, and at x equals 1. So we need to find the derivative of the function at 3 different points. So first we will find the derivative as a function. So this is question 1. So f of x is given as 4 minus x squared. And f of x plus h, we need to find it to use the definition. So it's 4 minus, instead of x, I'm going to substitute x plus h. and don't forget the square. You have to expand this bracket. Then we'll have x squared plus 2x h plus h squared, and then multiply the bracket by the negative sign. You will get 4 minus x squared minus 2xh minus h squared. Now use the definition. The derivative of the function is defined as lem so the derivative is defined as the limit as h goes to 0 f of x plus h, that is 4 minus x squared minus 2xh minus h squared. This is the first term in the definition, minus f of x. F of x is 4 minus, so this is minus 4 minus x squared. All these in the numerator. So the denominator will be h. So, okay. So here we'll simplify this. So we have lem as h goes to 0. So we have h in the denominator. And if you expand this bracket, if you multiply by the negative sign, then you will have 4 minus x squared minus 2xh minus h squared. And this is the negative sign multiplied by the bracket. We will get minus 4 plus x squared. See here, minus 4 and 4 will be cancelled. X squared and minus x squared will be cancelled. And then this will be simplified to, if we take the common factor, h, we will have minus 2x minus h divided by h. So the remaining here will be minus 2xh minus h squared. You take h as a common factor, then you will have h, and then multiplied by a bracket, and inside the bracket we have minus 2x minus h. So h will be cancelled with h, and then we will have the limit here. By direct substitution, see, I kept writing limit until the last step where we have to evaluate the limit. Now, by direct substitution, you substitute here h by 0, you will get minus 2x. So the derivative of this function is minus 2x. Now, if we want to find the derivative of the function at minus 3, then you say f prime minus 3 equals to minus 2 multiplied by x, which is minus 3, and you will get positive 6. And then f prime 0, you go back to this derivative function and you substitute x by 0, you will get 0. F prime 1, you substitute x by 1, you will get minus 2 multiplied by 1, you will get minus 2. So at these 3 different points, you will have 3 different derivatives. And don't forget that the derivative here means the slope of the tangent line to the curve at this value of x. So at x equals minus 3, the slope of the tangent line is equivalent to 6. At x equals 0, the slope of the tangent line is 0. At x equals 1, the slope of the tangent line is minus 2. Okay? This is 1. So I hope you understand the solution of this question. You can follow the same steps and find the answer to these questions from 1 to 6. The same thing for the other group of students from 7 to 12. You need to find the derivative as a function of x. Okay? So that's it for this session. Hopefully you understood it, and then I will see you in the class, inshallah. Bye bye. Assalamu alaikum.